Okay, we are going to blueprint a part. This is project 3. You should already have this in your packet. And we are going to draw, first we're going to cover the isometric views. So I'll place this on the paper, and I'm going to simply trace around it. Intentionally, I am using a purple marker on the end, which I'll show in a second why I'm doing that. So, okay, so there's an outline of our part. Now, these lines are object lines. They show details of the part, the outside of the part, the two holes. These are details that are seen all the way down the part. Now, orthographic views. When we lay something out, we have to look at it in a very particular manner. So these are called, it's called an orthographic view. So this is my front view. Now the front view is the view that shows the most detail of the part, and it's normally shown in the center of the print. It has no bearing on how the part lives in the real world. So I'm going to swing it to my orthographic view. Notice front view. And now I have another view. And this would normally be called a top view. Notice purple, purple, black, black. Back to my original. Upright. Now this entire one would be purple. See? I'm going to fill this in a little bit better here. Try to improve it. So there are our three views: a top view, or sorry, front view, top view, a right side view. You notice how it rolls through. Now, these circles, these holes, in this view, we can't see them, can we? They're hidden from our view. So we're going to take an X-ray of the part, and we're going to show these as hidden lines. And a hidden line is a dashed line. A solid line is an object line. So there we go. Now we could be fancy, and we could mark this with the part number. There we go. So now what we have to do is we have to start actually measuring the part and marking the dimensions. Now this is a inch and metric dial caliper, both in one. The red needle in part of the dial is metric. The outer black ring with the black needle is inch. So I will measure this, and I'm getting 2 inches 952 thousandths. So this is my dimension, which I'm going to circle in purple. Don't circle that, I'm just doing that for reference. This is an extension line. This is an extension line, a dimension, and these arrows are dimension lines. They are going from the dimension to where the dimension starts and stops, or it was taken from. I can do the same here. I'm getting 1 inch 950 thousandths. .950, and my thickness looks like it's 0.251, 0.252. Now here's the thing with this: 0.250 equals 1/4 inch. So I'm getting 0.252. Well, there's manufacturing tolerances on everything, including the thickness of a part. This was probably supposed to have been a 250 thousandths thick material, otherwise known as a 1/4 inch. So I'm going to leave off the 2. And I don't have enough room here to put 250 thousandths in here. So I am going to show it off to the side for thickness. So there we go, and we have the outside of the part. Now I showed this in this view instead of the front view. The reason I did that is it shows thickness where I'm actually seeing the thickness. So I could have put it here, or I could have put it here. Either one would have worked. So now what I'm going to do, previously I used the outside jaws. I need to measure those holes. That is not a very accurate or repeatable method of measuring the hole. Instead, I'm going to use the inside jaws. And I'm going to wiggle everything while using a thumb wheel to pull the caliper open. And I'm making sure I'm getting a good accurate reading. And I'm reading 357 thousandths. 335 thousandths. Let me double check that. Yeah, I read the first one wrong. 335. All right. The arrow points to the hole, leads me down, over, and there's my dimension with the diameter symbol. So this is called a leader line. I have bad handwriting. But this line leads me from the information to where the information came from. And let me push that up so you can actually read it. So we have length, height, width, diameter, and that is 2 holes roughly the same size, so 2x, 2 times 0.335 diameter. So now here's the fun part. Where are these located from the edge? Now I could do this poorly. I could read it from this edge to center or this edge to center and list them both, but generally you come off the same edge for holes. So I'm going to come off this edge over, this edge over. Now measuring from edge to center, well, is that the center? I can't really be sure. So what I'm going to do is I'm going to measure from edge of the part to edge of the hole. And I'm going to write that down. I normally wouldn't write this on the print because it makes the print look messy. I have 811 thousandths. I know the size of my hole, so I can take that, divide it by 2, and I'm going to get 150, 165, around 167 thousandths. And I'm going to add it to it. 978. Now, the thing here is from the edge to the center of the hole, but do I know that's a hole? I mean, it's hidden lines. It's 2 of them. Could be a hole. Could be a slot. I mean, I can't really be sure. So what if instead of putting it there, I instead put it down here. Now that looks sloppy, and if I did this in AutoCAD or SolidWorks or any of the computer modeling programs, I would simply click on this and pull this up to here and get it out of the way. But I'm kind of stuck because it's pen and ink. And this is the fundamental problem with pen and ink drawings. Once you write it down, it's there forever. So the other one, and here of course I drew right through the part number, which is another bad thing to do, but we're just going to live with it. I'm looking at 1 inch, 819 thousandths or so. 819.167. 1.986. So there we go. There's a print. Now this is probably supposed to be 2 inches because that's a little more normal of a number. Same with this. This is supposed to be 1 inch probably, but we're just going to leave those. So there we go. There's one part. And if I got really fancy, I could put aluminum down. And that's it.